what do you guys remember from last year about parallel and perpendicular lines? Okay, because that's what's so hard as we're going through things, is trying not to think about stuff we know from the past. Okay, Burgard, what you got?
Parallel lines have the same slope.
Okay, so parallel lines have the same slope. Now, thinking back to Josiah's question, what do we know is true about perpendicular lines? Brooke? Okay, that's not, let me clarify my question. What do we know is true about the slopes of perpendicular lines? Sarah?
Their product is -1.
Their product is -1. So if two numbers multiply to give me -1, what kind of numbers do we have? Opposites. Signs have to be different to get a negative, and they are reciprocals in order to get a product of 1. Okay? So our objective is to review parallel and perpendicular lines. And their slopes. So this comes out of lesson 13.3. And we actually have 2 theorems on this. Remember, theorem is something that can be proved. Now, they do make a stipulation, and they say two non-vertical lines are parallel if and only if their slopes are equal. Okay, so let's talk about this exclusion. Why do they have to exclude vertical lines from this definition? Isabel? Okay. Uh-huh. Undefined means we have no ability to come up with a number. So how can we say this number that we can't come up with is the same as this number we can't come up with? So by this definition, they have to exclude vertical lines. So then that bodes the next question. Are vertical lines parallel? Will they ever intersect? Do they meet that definition? I'm hearing yes and no. I'm not sure what the yeses and nos refer to. Somebody else other than Isabel has to do some thinking today. So can vertical lines be considered parallel or not? Okay. And why? Dakota? The definition of parallel lines are two lines that do not intersect. So by this theorem's wording, we exclude vertical lines. But vertical lines are parallel because by the definition of parallel lines, they meet the condition that they will never intersect, therefore they must be parallel. Okay? So it's kind of a weird, but it's the technicality of having a slope that's undefined. Because it's undefined, we can't talk about it. It's kind of, this is why people who do well in geometry become lawyers, because it's nitpicking the details. Okay? It's a technicality that we're disqualifying vertical lines through this theorem, but in reality, we know all vertical lines are parallel to each other because they will never intersect. Okay, Georgie, question?
No.
Comment? Hair play? Okay. Mikey, you had your hand up. Question? Comment? And you had the same answer? Okay, all right. So then we have another theorem. So again, geometry by technicality. Theorem 13.4 states two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. Okay, so in algebra, this was our secondary thought about perpendicular lines. Our primary thought was the numbers involved of perpendicular slopes. And so that's where we said slopes are opposite reciprocals. Now, the reason why I've always for years said negative reciprocals, but I found what happened is kids honed in on the word negative and always put a negative on their numbers. And that's not what it meant. Negative means the opposite of the other one. So we changed the word from negative reciprocals to opposite reciprocals, so you just understood that if this guy is positive, the other guy's got to be negative. If he's 3/2, the other guy needs to be 2/3. Those are reciprocals, but the opposite has to deal with a sign, okay? Otherwise, I was getting two negatives numbers, and then, because kids we don't focus in as much in the algebra class at the product. We focus more at what do the individual slopes look like. So we have two ways, and this is where this comes from, so you can see it played out, where according to geometry, if I multiply two slopes and I get -1, I know that my lines are perpendicular. Or I know if my lines are perpendicular, the product of their slopes will equal -1. Algebra, the relationship was more like this. The slope of 1 is equal to the opposite reciprocal. So basically that's what they're saying. So the lighter red, that's more the algebra concept that goes with this purple comment. And then the darker blood red goes with the theorem from the geometry perspective. Okay. Now again, we have a technicality here, right? Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Is that to say that vertical lines aren't allowed to be perpendicular with anything? No, it's just saying in this purpose, we can't multiply something that's undefined by something else. We can't do that. So how are we able to say, yes, we can have a parallel line that's perpendicular to a different line? What allows us to be able to include vertical lines as being part of a perpendicular pair? What would allow me to include a vertical line in that? Because it's this theorem excludes it. Dakota? Yeah. Two lines that make a right angle are considered perpendicular. Well, an x-axis and a y-axis, with the y-axis being the vertical line, they make a right angle, which measures 90. So we can conclude we have perpendicular lines through the definition of perpendicular lines if one of the lines is vertical. Okay? All right, so let's look at a couple things, and then you guys will be on your own to do homework. So you're going to be asked to complete a table given certain conditions. If line R is parallel to line S and line R is perpendicular to line T. So if you're having trouble visualizing this, you can go ahead and draw a picture of it. All right, so we've got slope of R. We've got slope of S. And by the way, one of my pet peeves is when you spell slope S-L-O-P, because all you've written is slop. So be careful with that. Yeah. I'm just erase these loose ends. Okay, so I'm going to give you, in the first one, the slope, of R is -1/2. In number 2, the slope of, T, is 1/6. In the third one, the slope of S is 1/5. In 4, the slope of S is -4. In 5, the slope of T is A. And in 6, the slope of T is 3B/4. So, what is the easiest relationship to write slopes for? Okay, I'm hearing some whispers, but not real loud, anything. R and S, why? Yeah, so if I know R, I know S. If I know S, I know R. Do I have any of those that I can fill in? Yeah, I've got quite a few, right? So on the first one, I know that R is -1/2, so I know that S is -1/2 because they're parallel. I know that S is 1/5, so I know the slope of R has to be 1/5. I know the slope of S is -4. I know the slope of R is -4. So those are the easy ones. Okay, bam. Now, let's go ahead and figure out, let's just stick with slope of R. So if R and T are perpendicular and T has a slope of 1/6, what's the slope of R in number 2? Anybody? -6. So it's opposite reciprocal. Okay? And then once I know him, I know S. Easy. Okay? If the slope of T is A in number 5, what's the slope of R? -1/A. Oh, that's lousy. This is why you need to make sure that you put your negative sign in the numerator is the best place, because otherwise it looks like one big huge long fraction bar. If I know what the slope of R is, then I know the slope of S. It's also -1/A. Okay? If I know that the slope of T is 3b/4, what's the slope of R in number 6? -4/3b. And now that I know what R is, I know what S is. -4/3b. Okay, and then let's go back to these guys. If the slope of R is -1/2, what's the slope of T? 2. If the slope of R is 1/5, what's the slope of T? -5. If the slope of R is -4, what's the slope of T? 1/4. Okay? Pretty easy, right? Just to get that relationship. Georgie?
On the column 2, are those B's or 6s?
B's. B's. On number 6, B. On number 2, 6s. 6s have a curvy back. B's have a straight back. Okay? All right, so I'm going to give you one more question. Everybody good with the chart? Yep. Yes. Okay. So if line K is perpendicular to line N, and N has a slope of 0, what is the slope of K? Okay, Burgard's got an answer. Anybody else? Plotkin's got one. Oh, we got Lauren's got one. Couple. We're slowly thinking. Lauren, what'd you get? No. Drake P. It would be undefined. And here's the reason why. Can we do this? Say the slope of K is -1/0. No. First, though, what I want to ask you this. What kind of line has a slope of 0? Horizontal line. What's perpendicular to a horizontal line? Vertical line. So a vertical line is perpendicular to a horizontal line, which makes him have a slope that's undefined. And then also this kind of verifies that it would be undefined because we can't divide by 0. Okay? All right, that's it.